Hi, this is the Karazu. We have here a coordinate geometry question that has to do with a circle, but also in a data sufficiency format. We already solved this question using algebra. Now we're going to solve this question using geometry. It may be easier to use geometry to solve this question for many of you because you like to see exactly what's happening with your own eyes. So let's go ahead and read the question and then solve the question using geometry. In the coordinate plane, point TS lies on a circle with center at the origin. What is the value of root of t squared plus s squared? Number 1, the circle has radius 3. Number 2, the point root 5 negative 2 lies on the circle. So what we're going to do here, we're going to draw a circle centered at the origin. So you're going to have this coordinate plane. You have x here and we have y here. Let's try to draw a circle here centered at the origin. It's not perfect, but bear with me. So here this is the origin. It's the point 0, 0. That's the center of the circle. And we are told that the point TS lies on the circle. So let's create a point here. So this is, if you can draw a line if you want. Since the x coordinate of this point TS is t, and the y coordinate is s. That's really what it means, that the TS lies on the circle. This is a point TS, t being the x coordinate, s being the y coordinate. You can call it p if you want. Okay? Now, isn't it this line, let's draw it, isn't it the radius of the circle? It's going from the center to the edge of the circle. So this is indeed the radius of the circle. If you know about right triangle, you should know the Pythagorean theorem. Before I use the Pythagorean theorem here, you should agree that I have just created here a right triangle. I'm talking about O, which is the center of the circle, P, and this point right here where T is. T is really not a point. It is rather the distance between 0 and T. T is just a coordinate. But there is a triangle here, OP, and this point right here. This triangle is a right triangle. It is a right triangle, obviously, because I'm projecting P. The projection of P on the x-axis, it has to be a right projection. It has to be done in a perpendicular fashion. Okay? When you do a projection, it's following a perpendicular angle. A right angle, I should say. So this right here, from this point to P, we can call this point anything you want. Let's call it maybe Q. Okay, this point right here is Q. It's crowded here. Okay. QP or PQ if you want is also S. The distance Q and P is S. Remember, 0 to this point is S. So Q to P is also S. So because this is a right triangle and because of the Pythagorean theorem, we can say that T square plus S square should be equal to R square. This leg square plus this other leg square has to be the hypotenuse, which is the radius here, squared. But on number 1, we are told that the circle has radius 3. So t squared plus s squared should be equal to 3 squared. Consequently, t squared plus s squared is obviously 3. And we just have found the value of root of t squared plus s squared. So indeed, number 1 is sufficient. Okay, let's go to number 2. Number 2, we are told that the point root 5 negative 2 lies on the circle. In order to avoid any messy drawing here, I'm going to redraw the circle quickly. XY here, and we have a circle, maybe something like this, okay? And we're going to put the point root 5 negative 2 on the circle. Root 5 is about 2.2, really roughly 2.2. So if you want, this is the x coordinate. So we're going to say that it's maybe, let's just say this is 1, okay, and maybe this is 2. So it's around here if you want. That's root 5. Okay, it's the x coordinate. What is the y coordinate? The y coordinate is negative 2. So really, if you want, maybe 1 here, 2, and 3. So it's going to be on the circle. So it's going to be, let's say here. This is a point we're looking for. Okay? So we can draw this. This is again root 5. And this here is negative 2. Negative 2. Okay? Root 5 and negative 2. And this is the point that lies again on the circle. Now, we can draw again the radius of the circle by connecting the origin to this point. We can call this point, again, we can call it, let's say P1 to distinguish it from this P here. So OP1 is the radius of the circle, it's R also. The Pythagorean theorem also tells us, because we have just created a right triangle here, that root of 5 squared plus negative 2 squared is equal to the radius squared. Again, compare this with compare this to the first drawing I did here, and you should agree that we can say that root 5 square plus negative 2 square equal r square. It's like s and t here, root 5 being equal to t, negative 2 being equal to s. So what is this? This is the same as 5 plus 4 is equal to r square. So 9 is equal to r square, and this means that r equal to 3. Now look at, this just is the same as number 1. Number 1, we are given that the radius was 3, and we were able to solve the question. It was sufficient. So using number 2, we are able to find the radius of the circle, which is 3 here, using the Pythagorean theorem and just the geometry of the circle. And then we can tell also that number 2 is sufficient, because again number 1 was sufficient and we had the same information essentially. Number 1 is sufficient by itself. Number 2 is sufficient by itself. So The correct answer to the question should be D. D is the correct answer. Okay, so what we have learned here is that we can do the question the geometric way using a circle, the drawing of a circle, and using the Pythagorean theorem. Here you were able to find out how to draw the circle, how to put a point on a circle, how to use a projection of the circle, of the point on the circle to find the x coordinate of that point and the y coordinate of the point. And then we're able to use again Pythagorean theorem to find the radius of the circle and to find the value of root t square plus s square, which is exactly actually the radius of the circle, as you can see here. Root of t square plus square is exactly the radius of the circle. Now, I think that you should compare this way of solving the question with the way of solving the question algebraically. And I did that in a different video. Watch both videos and figure out which one you prefer. Okay? I think that you learn a lot about the circle by knowing both ways of solving the question. Again, thank you for watching, and this is Dakarazu.